Okay, now let me show you the example of basic differentiations. So if I have given y equals to this 4x cubed minus 3x squared plus 2x minus 1, and you need to find the differentiation, the first differentiation, which is dy over dx. It's quite easy, it's quite simple, and what we need to do, as we see this, there's power 3, okay, then the power, it moves from 3 times 4x, and the power itself you subtract by 1, so it's gonna be 3 minus 1. Minus, we repeat that procedure. So I have 2, I move it down, 3x power of 2 minus 1. That's it, guys. So plus 2x. Actually, you can follow that one also, or else you can just directly put 2. As you know, this is only power of 1. Okay, but if you want to follow it, it's okay as well. You will see how it goes. So it's gonna be 1 minus 1. Okay, minus, sir, I don't have x here, this is constant. You know the rule of constant, actually it becomes 0 right away. But you also can follow this procedure. Actually, it's rooted from this one. So it's gonna be 1. Actually, this one, I have an imaginary x to the power of 0. Is it? So if you want to use this one, it's also possible. So I have 0 times 1, x to the power of 0 minus 1. Okay, so my dy over dx, it becomes 12x squared minus 6x to the power of 1. Let me just leave as x, plus 1 times 2, x to the power of 0. This is 0, right? Okay, let me just put it there. X, 0, 1. That's gonna be minus 0 times 1 times x to the power of 0 minus 1. Okay, 0 times x power of minus 1. Okay, so the final form, what I have is gonna be 12x squared minus 6x. X to the power of 0 is 1, right, guys? So it's gonna be 1. So what I have is gonna be plus 2 only. This one, 0 times x to the power of negative 1. Sir, this is x negative 1. It's okay, but we times it by 0. So meaning 0 times with anything, it becomes 0. So the final form of the differentiation, it would be 12x squared minus 6x is 2. If you have questions, you can drop in the comment section. Okay, let's move on to the next example with dy over dx. Okay, so this is, as I told you, this is a little bit more complex, a little bit only, because we cannot directly find the dy over dx before we convert it. So we need to convert it in order to get the power. So it's there is root here, so it's gonna be x to the power of 8 cube root of x to the power of 8 minus 4th root of x to the power of 7 plus 5th root of x to the power of 6. So it's gonna be difficult if we directly find the differentiation. So we need to convert it first, guys. So let's do it. Okay, based on exponential rules, I have this one. I can convert into x to the power of 8 over 3 minus x to the power of 7 over 4 plus x to the power of 6 over 5. That's it. And if we want to find dy over dx, we just use the same protocols. Okay, so the 8 over 3, we move it from x to the power of 8 over 3 minus 1 plus, minus 7 over 4 times x to the power of 7 over 4 minus 1. That's it, guys. What you do, just do the rest. The same with the rest. Okay? Then let's calculate that. Okay, so the dy over dx, it would be 8 over 3 x to the power 8 over 3 minus 1. Remember, 1 is going to be 3 over 3, right? So it's going to be 5 over 3 minus 7 over 4 x to the power of 3 over 4 plus 6 over 5 x to the power of 1 over 5. This is actually done. But if you want to make it into better shape, yes, you can do it by put it back into root form. Okay, so it's gonna be 8 over 3. See ya? So it's gonna be x to the power of 5. This one is gonna be cube root because we have over 3. Minus 7 over 4 x power of 4 cube root. Sorry, my bad. Power of 3 and cube root. Fourth root. See, power of 3 is gonna be fourth root. And same as this, I have x root of fifth root of x. Okay, so this is, I think, the more proper way to provide, but it's actually up to this point it's already done and completely correct. Okay, if you have questions, go ahead. You can drop in the comment section. Thank you guys. See you.